Welcome to another stream. How about that? About that? Bet you didn't expect that shit to happen yet again. Nobody fucking expects that every fucking time, but here I am. Yet again. You can't get rid of me that easily. Hello everyone. So today is Friday, if I'm not mistaken, and that means today we're supposed to be doing one-off stream. That's right, we're doing one-off stream. And it means today I'm supposed to pick a topic and stream it for a single stream. But since yesterday we were doing Advent of Code and I completely failed day 10. So I decided to spend a little bit of time before, like at the beginning of the stream, to do some sort of like a post-mortem of that day, because yesterday also after the stream I looked up the solutions and studied them, and now I understand what was my problem. So yeah, let's talk about that. So the solution to this problem, so let's actually open up the problem. Let's open up the problem. So I think it was 2019, day 10. So yeah, I got actually spoiled, but I think I learned a couple of things. First of all, I'm extremely disappointed that you can literally use floats for angles and it will just work. So essentially you can just code the dumbest solution where you just take the angles and the input data doesn't have any pitfalls or anything like that. It will work. Seriously. Yeah. So the thing I suppose I learned is that I should not be shied away from the dumb solutions in Advent of Code. The thing is, I participated a lot in competitive programming, and the competitive programming taught me that you should avoid the simplest and obvious solutions because they probably have the test case for that. Advent of Code is not about that. Yeah, the competitive programming would have prevented that, but apparently you can literally do that and it will work. So, yep. So let's go ahead and solve it, I guess. I already solved it, right? I already got the 2 stars. I'm the 2-star champion of this problem. But I want to solve it from scratch on the stream just to document the proper solution in Haskell. Because actually in Haskell, this solution is very interesting. And specifically part 2 is very interesting in Haskell, because part 2 requires like maintaining the state a little bit, and maintaining that state in Haskell a little bit challenging. But if you utilize a couple of laziness tricks, it's actually not that difficult, and it's actually a very interesting challenge by itself. So let's actually try to do that. So what do you guys think? Let's do a little bit of Haskell coding. By the way, hello everyone. I forgot to greet everyone. Hello Mr. Botka, Hamikovi, Iguduk, Rotten Chauncey, Cerimon, Useless Pony. Hello, hello, really glad to see you all today. So yeah. Oh, by the way, speaking of, I looked up the solution in Zhiyang's repo. So Zhiyang is one of the oldest viewers of mine, and he's an incredible coder. He's an actual god coder, and he solved all of the Advent of Codes. So, and he posted all of his solutions here. So I think from now on, I'm not gonna basically torture myself trying to always come up with the solution myself. If I get stuck for like several hours already solving, I think I'm gonna go and look up the solution in Zhiyang's repo. I think it's gonna be like better for everyone, right? So I won't be suffering and you won't be suffering watching me suffering. So yeah, basically from now on, participate in Advent of Code. If I cannot solve the problem, I will just admit that and look up the solution. At least we will learn something. So yeah. I'm not that good at competitive programming, so even though I participated in competitive programming in the past, I never get good at it, because being good at competitive programming requires like a special kind of brain, which I unfortunately don't have. So no matter how much I practice, it just doesn't really work for me. So yeah. Okay, by the way, you may notice that we're listening to new music. This new music is by Pilot Red Sun, so you can find the album that we're listening to here if you're interested. Demoted to democrat, yes. Alright, let's actually go to the Coding AoC, AoC 2019, and let me remove the day 10 and start over. Right. Stodding. Stodding, what? Alright. So... did I tap it? Stodding? God damn it. Alright, should we read the description of the problem one more time? Maybe we should, just for the documentation purposes. Because I'm going to upload both of the VODs on YouTube. Alright. But in the main 5 hours VOD where I failed, I'm gonna redirect to this VOD where I, explained the solution and did the post-mortem. So I think we wanna still read the description of the problem. So let's quickly do that. So what we're solving monitoring station, right? You fly into the asteroid belt and reach the Ceres monitoring station. The elves here have an emergency. They are having trouble tracking all of the asteroids and can't be sure they're safe. The elves would like to build a new monitoring station in a nearby area of space. They hand you a map of all of the asteroids in that region, your puzzle input. The map indicates whether each position is empty, dot, or contains an asteroid hash sign. The asteroids are much smaller than they appear on the map, and every asteroid is exactly in the center of the marked position. So here's the thing about this problem, right? It makes it, the description makes it sound like it's on a grid, but it's kind of like a fake grid. So the positions, all the positions here are continuous value. It's just the asteroids are located at the centers of the imaginary grid, but all of the calculations has to be done in the floating point, right? And I suppose one of the things, the size of the asteroids is like a point. You should treat them as sizeless, but they have position. Yeah, and you have to solve all of that considering this. The asteroids can be described with x and y coordinates, where x is the distance from the left edge and y is the distance from the top edge. Another thing to consider is that the coordinates are inverted. Y goes down, it's a screen coordinates. From the top edge, so the top left corner is 0, 0, and the position immediately to its right is 1, 0. Your job is to figure out which asteroid would be the best place to build a monitoring system, and monitoring station can detect any asteroid to which it has a direct line of sight. That is, there can not be another asteroid exactly between them. This line of sight can be at any angle, not just lines aligned to the grid diagonally. The best location is to detect the asteroid that can detect largest amount of asteroids. So essentially, this particular position, I think it can detect this asteroid, you see? So you can detect that one from this one. So this is because it goes through this imaginary hole. So you see, everything has to be in floats. Ava, thank you, Witness, for 13 months. Wait, 20 months of Twitch Prime subscription. Thank you, and welcome to our epic advent of Code Club. That's right. So yeah, and our input is just, this, right? Something like this, and you have to find the position for which you can see the maximum amount of asteroids, right? So yeah, essentially the easiest thing to do here is to take go through each individual asteroid, right? And for each individual asteroid, basically group them by their angles, right? And the amount of groups you have is the amount of asteroids visible, right? So essentially you have this thing, you go through all of them, you calculate angle relative to this one for all of them, then you group them by their angles, and this is your answer for that particular asteroid. The amount of these groups is the amount of visible asteroids, because this is the amount of rays you have. And that will work if you just use angles as floats. Seriously, the input data doesn't have any pitfalls, and my first mistake that I did while solving this problem is that I thought maybe the data is going to be so tricky that if you try to do something like that, it won't just work, so we'll have to avoid floats, because that's what I was told in competitive programming, but apparently data is actually quite dumb. So yeah, that's the first lesson I learned, you always assume a very dumb solution. Let's quickly do that, I suppose. What do you guys think? Let's quickly solve this. So let me grab the data. Input data. Where's the? Yeah, get input. Yeah, and the input is actually quite small. This is the whole input. So what do we have here? Emacs, and let me do input txt, and I'm gonna grab the input. There you go. So what we'll need in our program, module main where, right, we'll need to introduce the point, right? We'll need to introduce the point that indicates the asteroids, right? So we're gonna just implement like a 2D vector. Deriving equal show. There we go. There we go. And I think I need to restart my Emacs, so I can use my GHCI. Cool. I'll need to wait a little bit. For example, for some reason, first run of GHCI is super slow on my machine. Yeah, so we also need to define the entry point here, otherwise it's not gonna work. Entry point is very important. Sundari Tubeworm, hello, welcome, welcome, fucking welcome. How are you doing? Alrighty, so we have this point, right? Let's write some code. Yes, exactly. Okay, so let's read the input file, right? So this is how we read the input file. And again, I want to split the input file by lines. I want to split it by lines. And maybe I also want to... I just lost my thing. I also want to enumerate each line, right? So but, the easiest way to enumerate anything is to zip it with 0 ... All right. So imagine that you have a string, hello, and you want to enumerate each individual character here. So you can zip 0 like that, and what you get is a list of pairs, index, character, index, character, index, character. So, and the reason why you can do that is because string is a list of characters. So this is one of the things in Haskell, is that strings are literally linked list of characters. Yes, it's not a joke. In Haskell, strings are linked list of characters. Welcome to Haskell. What can I say? So, and essentially, if you have lines, you can map each individual line with this thing, zip 0, and that will enumerate each individual character within each individual line. But then you want to enumerate each individual line as well, right? So, and that will give you a type, a very interesting type, list of pairs where the first element is an index, a second element is another list where you have a pair of a character of the coordinate and the character. So this is a very, very complicated type, but it allows you to index two-dimensionally x and y. So after that, you want to map each individual line, and each individual line starts with yeah, so essentially you start with y and a bunch of x's, right? You start with y and a bunch of x's, and within each x, right? Within each x you have x and a value, right? And what's interesting is that you probably want to filter out everything that is not an asteroid, right? So the way to do that is probably do the filter. Actually, oh my god, I'm gonna sneeze. Ah! Oh, oh, very sorry. Oh, thank you so much. So within each individual line, we want to also filter out all of the non-asteroids, right? So this is what we want to do here. Maybe not. Maybe we want to actually like turn all of that into a sequence of. Yeah, let's try to do that. So within each individual thing here, we're mapping it, and we end up with y and a bunch of x's. Within the x's, I want to filter those x's. Right, so x's have a character at the second thing, so I want to see that the second is equal to a hash, and that gets rid of all of the non-hashes, right? That gets rid of all the non-hashes. And after that, I want to map this entire stuff into, well, yeah, we want to map it and get rid of the characters. So we're going to extract only first, so we really have the list of x's. And after that, I want to map this entire thing, get the x and turn it into x and y, but not really x and y, actually vector x and y like this. And it didn't really work because why? Because I'm supposed to be using dollars. I keep making, yeah, there we go. So now I have a list of all of the asteroids, and I have to actually concat map this entire thing, and there we go, I got my input. So this is how we parse the input. So basically you have to make this like sophisticated query, but that will work. Are you a software engineer? Yes, I am. I do consider myself a software engineer, whatever the hell is that supposed to mean. Because different people understand different things by it. Parse input. So we're gonna accept a string and we're gonna return a list of these points, right? So this is how we parse the input. So to be fair, maybe we have to do it like that. There we go. Okay, so it's gonna be like that. We read the file, and then I can parse the input. Hello, shutdown 1510. Welcome to the show. And yep. So I have to actually penetrate this entire thing. Oh my god. Parse input, read file, input txt. There we go, cool. So now we are capable of parsing a file. So now I need to be able to calculate an angle of the vector, right? So since we're going for very dumb solution, we're gonna just go ahead and have a function that accepts a vector and returns us a double. So to have the signatures a little bit more descriptive, I think I'm going to introduce an alias for radians, right? Because the angles usually measured in radians, so we're going to have rad. So you have an angle that takes a vector 2 and returns radians. So, and the easiest way to do that is to use a tan2 function, which accepts y and x, and basically something like a tan2 yx of a vector is equal to our arctangent y divided by x plus additional corner cases checking and stuff like that. Actually, you can check it out here. So if you go to a10.2 on the Wikipedia page, you'll find the definition of that function here. Yeah, something like this. So this is actually a pretty good definition, right? So you have a bunch of cases. If x is greater than 0, then that means it's arctangent of y over x. If it's less than 0, arctangent y over x plus pi, and so on and so forth. And the only value for which our a10.2 is not defined is when both x and 0 are equal, both x and y are equal to 0, but we're never going to have that situation, actually. We'll make sure that we never have that situation. You can check it out here, by the way. So yeah, what's funny is that even if you try in Haskell do something like a10.00, it will not even crash, which is kind of interesting because the prelude of Haskell is actually really well known for crashing a lot. For example, if you take a head of empty list, it will crash because it's not defined. Yeah, this should never happen, exactly. But for some reason, a10 of 00 never fails in Haskell library, which is kind of strange. Actually, let me check out. Did they even try to handle that, or did they just, you know, didn't care about it? That's really interesting. I just need to wait. So it's not gonna jump to the corresponding function until the whole page is loaded up. There we go. Yeah, web. It's not really web, it's just Haskell likes to generate these huge pages for no reason. And yeah. So what's the definition of a10.2? We don't even have a source code of this thing. So it's just, okay. A version of arctangent taking two real floating numbers for real floating x and y computes, returns the value. It follows the common semantic for origin when signed zeros are supported, and definition is provided, but implementers can provide a more accurate implementation. Okay, so we don't even have an implementation proper. Interesting. Alright, there is also a function that checks whether something is IEEE floating point number. Do we even deal with non-IEEE floating point numbers these days? I think that's the only standard that is used these days. Did I miss the definition? Oh, there we go. Yes, I missed it. Ah, god damn it. Just a second. I need to restart this entire stuff. Okay, must be after other 00 tests. Alright, so they just decided to do it like that. Sure. Mods? Scroll down. Alright, so they decided to define it. Sure, fair enough. Okay, so we're gonna do the following thing. So we're gonna destructurize this entire thing. It's just 0. I mean, yeah, it's just 0. And we're gonna do a10 to yx. So interestingly enough, I guess we're gonna end up with the same angles anyway. We don't really need to normalize anything, right? So yeah, we can just use this angle. Is advanced mathematics used a lot in this engineering? Depends on what you mean by advanced mathematics. Like derivatives, integrals? No, not really. Depends on what you do. Yes. I just watched One Punch Man came to stream. Guess what happened? Ah, I see. Very funny. It's a very original joke, by the way. Alright. So we have an angle. Right. And now we want to calculate like angle for two vectors actually, right? Because we're gonna have a starting point and the destination point. So let's implement something like angle between, which accepts 2 points. Right. And we'll need to implement the difference between the vectors. So let's actually quickly do that. So vector 2, and x1, y1, x2, y2, and we're gonna actually have this thing here. Yeah, it's a very kawaii operator, I know. So it's just a difference between two vectors. Because what's funny is that I didn't invent that operator. I just stole the idea of that operator from the linear algebra package of Haskell. I think linear... let's call it linear. So index... Yeah, there we go. So here it is. It also has plus, but yeah. So this is how it's done. So it's a well-established package for linear algebra in Haskell. So if anyone is interested, you can find it here. All right. So, and the second one is going to be y1, y2. So this is the difference. And if you want to find the angle between A and B, essentially you'll have to subtract A from B and find an angle between them. And there you go. So you'll be able to find the angle between them. So, oh yeah. So here's an interesting thing. Y and X are integers, so we'll need to convert them to floats first. So anything can become an operator in this godforsaken language. Yes, actually, anything can become an operator if it starts with special character, I think. Yeah. And what's interesting is that this particular feature of the language is really abused by Haskell developers. People say that Haskell is very unreadable because it has all sorts of weird operators. The fact is, it doesn't have any sort of built-in operators, but it has a mechanism for defining your own operators, and it's just the Haskellers who abused that to oblivion and made the language completely unreadable, but you don't have to do that. And also you can turn any function into infix using backticks, yeah, sure. All right, so from integral, right? From integral. Cool, so now we can calculate this kind of stuff and it compiles. Cool. So the next thing we probably want to do, we want to implement a function that basically counts visible from a particular function. Count visible from. So it accepts vector 2 and the rest of the vectors. I think I want to like have a special type for this thing, right? So I already introduced it in my first attempt at solving this. I called it region, I think. So region is essentially a list of these vectors. And I'm gonna call it a region, and I think it would make sense to rename this entire thing to a region. Okay. Point free notation can hurt. I don't know, I guess it's... Can you quickly summarize what you're doing? I'm solving Advent of Code Day 10. That's as quick as I can summarize it. Alright, so count visible from, and that should return an integer, right? So it basically counts all of the visible from, and we kind of assume that this point is not within this region, so we'll have to always remove it from the region before actually applying it there. So we have A and a region, and there we go. So what we want to do here, we want to take the region, right? So, and essentially we want to group all of the points within their region by their angles between A. So one way to do that, so we have functions like group, right? We don't have them, sure. So let me see, because we need to import data list. Right. So let me remove that. So there's a very interesting function called group, right? So if you have a list like this, 2, 2, 3, 3, 3, it can group it like that. As a matter of fact, we also have group by, which can group it by any sort of comparator operator. But the thing is, it only compares nearby elements. So if you have functions that, you know, are not sorted, this stuff is not gonna really work, right? So if you try to group it like that, it's not gonna group anything. It actually will create a separate group. So you need to sort the elements first. So if you try to sort it first, like this, and only then group it, only then it will create these kind of groups. So first thing we'll have to do, we'll have to sort the points by their angle, and then group them by their angle. So I think the easiest way to do that would be to actually map each individual point to angle between A. So we take the whole region and we map it with the angle between A. Then we sort it, right? Sort by, you can use sort by, but not necessarily. You can use sort by. This is a Haskell. Sort and then group. I hope I didn't make any mistakes. So you have sort and group, and then you essentially can just do length, right? So you calculate the length, and that gives you how many of these things you can see. So essentially, if you group all of the points by their angles, you get each group is a ray starting from that particular position, and the amount of rays is basically how many asteroids you see. That's it. So I thought this solution won't work, and that's why I try to avoid it. So let's see. All right. So count visible from, and this could be like used here. So let's do part 1. So let me actually see if this compiles or not. Part 1, and so what we're gonna accept here, we're gonna accept the region, I suppose, and let's return pairs, I suppose, from int to vector2 region, right? So, and we're gonna just iterate through each individual point here from the region, and then we're gonna do count visible from A and a region, but you need to exclude that point from that region. Maybe you don't have to do that, but I want to do that just in case. Right, so that gives us count visible from. And then, so let me actually put it like that. I want to put the value first. All right. It's not a part of the language, I defined it. So I just defined it here. All right, so let's see if it's gonna do something. So let's actually have some sort of a sample, because I want to double check that I didn't make any mistakes. Double check that I didn't make any mistakes. So this solution should have 3.4, right? So does it compile? I will read file, sample 01, and then parse input. Right, parse input. It's actually parse region. I forgot. So there we go. So we have a parse region, and then I want to do part 1 and see what's going to happen. So yeah, 3.34 is exactly 8, and it's the maximum. So another thing we can do here. By the way, what has to be the output? I forgot for the part 1. What has to be the output? How many other asteroids can be detected from that location? So it's just amount. Okay, so that means I can kind of ignore this entire thing. Right, I can kind of ignore this entire thing and just do int and just do maximum. Maximum, there we go. Yep. Did it actually... Okay, so it's 8. Cool. So for my input, we expect 344. Will it work for 344? Let's find out. So it's going to be input. And it worked. So yeah, apparently the dumbest solution you can come up with using floats and shit like that apparently works. The input is not basically crafted to screw you over or anything like that. You can just do that. So yeah, that's pretty that's pretty disappointing, I would say. Like, I was really disappointed when I realized, like, yeah, the dumbest solution will work. The problem does not require you to do anything like fancy or anything specific. Just use fucking floats and it is what it is. It is what it is. Though I solved the first part, I think, in a more smarter way, a little bit more smarter, like using, like, you know, linear equations and stuff like that. So well, I mean, I basically overthought the problem. And again, it also worked for the second part. It also works for the second part. For the second part, you also can use the dumbest solution. But for the second part, you kind of... yeah, you will need to maintain this state, right? Because you keep circling around and shooting. Okay, let's actually read the description one more time, right? So, because we're, you know, making it as a separate video. So, once you give them the coordinates, the elves quickly deploy an instant monitoring station to the location and discover the worst. There are simply too many asteroids. The only solution is complete vaporization by giant laser. So fortunately, in addition to an asteroid scanner, the new monitoring station also comes equipped with a giant rotating laser, perfect for vaporizing asteroids. The laser starts by pointing up and always rotates clockwise, vaporizing any asteroid it hits. If multiple asteroids are exactly in line with the station, the laser only has enough power to vaporize one of them before counting its rotation. In other words, the same asteroids can be detected. The same asteroids that can be detected can be vaporized, but if vaporizing one asteroid makes another one detectable, the newly detected asteroids won't be vaporized until the laser has returned to the same position by rotating full 360 degrees. Yeah, so, and essentially you just have to rotate around and vaporize the asteroids. And the thing you have to answer. The elves are placing bets on which will be the 2000th asteroid to be vaporized. Win the bet by determining which asteroids that will be. What do you get if you multiply its x coordinate by 100 and then its y coordinate, and add this its y coordinate? All right, so how you can do that? Essentially, you can repeat this idea. You can, since you know the station now, right? So the part 2 is going to also take the station and the region within which you have to work, right? So you can basically do the same thing. You can group everyone by their angle. Right, you can group them everyone by their angle, but since you have to rotate, you need to sort them by their angle. You need to sort the groups by their angle, and within the groups you have to sort them by their distance. So, and once you get this data structure, once you establish this data structure that is sorted by angle, and within each group it's sorted by distance, what you need to do, you just need to iterate over that data structure over and over again and just pop the asteroids, and do that 200 times. Yeah, but doing that in Haskell is actually a little bit challenging. So I'm gonna show you why. So let's actually emulate that process. Imagine that you have a bunch of lists, like so. This one is from 1 to 5. This one is from let's say 6 to 7, and this one is from 8 to 11. So you have this bunch of lists. How would you do that in Haskell? How would you do that in Haskell? So if you are not very experienced in Haskell, what you would do, you would have a function, right? You would have a function, you would accept this list like that, and you would return this list like that. And basically you will carry this state along, and it will be very huge and cumbersome code that is very difficult to understand and very difficult to update. And even write and also troubleshoot, so there will be all sorts of problems. So can we do that a little bit better? Is there any better way and more Haskellish way? Well, we can do that by exploiting laziness of the language. Okay, so let's imagine that you have something like this, right? So we have x's. So then, since you're wrapping around the list over and over again, in Haskell, going over the list over and over again is done by using infinite data structure. So in Haskell you even have a function called cycle, right? So it accepts the list from 1 to 5 and returns you an infinite list that wraps around indefinitely. So this is how you simulate going indefinitely in the list. You just basically construct infinite lists. Alright, so you have this thing. So to go around this list over and over again, you have to turn it into an infinite list. But each round of that list has to not have a head value of the elements. You see? So on the next round, you have to decrease the size of the list. You have to pop off the heads from that list. How you do that? You define a new variable called y's. The variables start with x's. This is the first round. The second round is y's. You see, we define y's in terms of itself. Why this will work? This will work because Haskell is a lazy language. Right, so that means the variables can be defined in terms of themselves, and this is a way to construct infinite data structures. So next thing you do, you map each individual element of that y's with tail, and that constructs you infinite lists. So if you try to take 3 elements of that list, here are your groups with all the elements intact. But if you take the 4th one, you will have the first element without its head. Then if you take even more, you will have the second element without its head. And if you take the 6th one, you have the 3rd one without its head. And if you go any further basically removes each individual head. So essentially, once you have this list of groups, you construct infinite data structure that gradually chops off its heads, and you just need to take 200th element of it and look at its head. That's how you do that That's how you do that in Haskell. This is the Haskell way of doing that. And it's way easier to do it this way than trying to maintain like a mutable data structure and stuff like that. So this is like way better in my opinion. All right. So what's interesting, this is not enough. So at some point, you will probably reach a situation when one of the groups is actually empty, and you will try to take a tail of an empty group. So if I do something like 100, at some point you try to take a tail of an empty group. So to avoid that, so we need to slightly alter the definition of this entire thing. Essentially, we need to add a layer of filter not null, right? Need a layer of filter not null. So essentially, if this definition encounters an empty list, it will remove it from the entire series. So once you exhausted asteroids and ones of the list, this group will not appear ever in that infinite list anymore. So that's another way of doing that. But we are redefining some stuff here. Filter. But yeah, it has to be actually done like this. Yeah. So it's all about operators. So yeah, so the only thing we need to do for the part 2 is just to construct this list of groups and just do the magic of infinite data structures. So, and it's going to be then as easy as just taking 200 element of it and just looking at the head of it. All right, so here's the part 2. So here's A and here's the region. As a beginner in this field, I don't understand too much. Which field, by the way? But it's so refreshing watching Sodium for some reason. Okay, sure. Maybe because I slept and I'm fresh and that I'm translating my freshness to you, I suppose. I don't know. Maybe that's what I'm doing. Anyways, so what we're gonna do here. So now we cannot just map you know, angles of this region and just sort and group all of that because we need coordinates. So if we map angles, we're losing information. So let's do this stuff slightly differently. Instead of sorts and groups, we're going to use sort by and group by, which does not modify the original elements. Right, so this is what we need to do here. Okay, so I'm gonna put access like this. So map, not really map, I'm gonna do sort by origin. Right. So how we do that? Sort by, compare on angle between A and the rest of the thing. Right, so this is how we sort them. So everything is sorted by angle now. But we don't have this function here. So to have this function, we'll have to do data function. Right, so here's the data function. Then we need to do group by, and this is going to be equals on angle between A. Right, so that will create this kind of group. Cool. So now we have groups, and they are automatically sorted by their angle. Right, they're already automatically sorted by their angle. This one has to be a dollar. But now we need to map each individual group and sort each individual group by compare on distance, distance between A and that point. Right. So to do that, we'll need to have a function that computes distance between two points. All right. So it's going to be distance, right? And again, like I'm just using like floats and you know. It just fucking works. Alright, so this one is gonna return double. It's gonna be A and B. So I'm gonna do the following thing. Len by minus I, and length for a single vector is gonna be just this. Alright, so wait a second. I just realized that I have an autoplay on. Alright. So, and to calculate the length, what we have to do, we have to take a square root of the sum of squares. Yeah, DMCA is coming. DMCA is coming. Alright. So once we have that, here are the groups, essentially. To be fair, we can remove a from the origin somewhere here. So I'm going to do filter not equal a right here, and that should be okay. So will it compile? We don't have a sqrt. This is because x and y are not floats. So we'll have to... Can I do something like this? From integral, like that, and okay. So in here I have to use the vector operator. I'm gonna use the vector operator. There we go. That works. Cool. So now I need to define an infinite list, right? So it's gonna be y's. I take x's and then I filter everything by not null from y's, and I map everything with tail, right? So then what I need to do, I need to just take 199th element of that list. So since they start from 0, right, I have to take 199th of it. And after that, I have to take a head of it, like this. And the head will contain the 200th asteroid. So I might as well actually, you know, destructurize it somewhere here by x and y. And since we need to, we need to construct the result, right? So multiply x by 100, so x multiplied by 100 plus y, and this is going to be the result. This is going to be the final result. So let's try to compile that, and something does not work. Filter is applied. Okay, that's true. Cool. All right, so that's basically the solution, but it won't work. We can try to do that. So expected results is going to be 2732, and part 1, yeah, there we go. So this is going to be part... Oh yeah, for part 2 you also need the position of the station, right? You also need the position of the station. So let's actually do a little bit of refactoring here. So first we're gonna read the file, input.txt, and parse regions, right? So this is gonna be a region. So you parse the region. So did I do that correctly? And then, so in part 1, we also want to return not only the final result, but we also want to return the station. So yeah. So here is that. Maybe I want to do it like that. It's going to be A, like this. And what I want to do, I want to find a maximum by compare on second. Yeah, I think we'll have to do compare on second. Compare on SND, so that will return us that. So after that we're going to do part 1, origin, right, and it will return us the station. Maybe we'll call it A. So it's going to be answer 1. So, and that is going to be like this. It's going to printf part 1 answer. So this is part 1. The part 2 is going to be like this. Part 2. Part 2, A, and origin. So you see, so in the first part we calculate the station and then we use that station for the part 2. So this is how we're going to go about that. Alright, so this has to be let. And we don't have printf because we need to import text printf. There we go. Okay, cool. There we go, there we go. So, yeah, if you try to compute now this thing, so it will take some time to compute this thing, and as you can see it's 2912, but our expected results is 2732. And this is due to the coordinate transformations, right? So let me show you what's going on here. It's actually very, very like artificial difficulty trick, tweaking, right? So this coordinate transformation, like, it doesn't really serve any purpose except to just screw you over. Yeah, so, but let me show you. So I just need to wait until my paint. Okay, so all of the computations are done in the following coordinates, where you have x, like positive x here, and positive y here. But our coordinates that we work with are actually opposite, right? They're actually opposite. So they look like this. So x is pretty much like the same as that one, but y actually goes down. Right. And on top of that, the gun, or whatever the fuck it is, it actually starts at the top, right? So it points up, right? It points up. So if you think about it, so when you point up, pointing up should be 0 degrees. Since we go clockwise, right? Clockwise should be 90 degrees or a half of a pi, right? So it should be half of a pi, like this. Then going in another quarter is going to be pi here, right? And going another one is going to be 3 pi over 2, whatever the fuck it is, right? So whatever. But when we are doing computations, right? When we are doing computations, well, let me pick the quarter. Our 0 is here, right? Our 0 is here. Our pi 2 is here. Our pi is here. And our 3 pi is here. So, essentially, to compute everything properly, what we need to do, we need to take our angles and rotate them 90 degrees, like this. Actually, we'll have to sort of rotate them in an opposite direction, right? Because if you have 0, it has to be pi 2, right? If you have 0, it has to be pi 2. That means if you have an angle, what you have to do, you just have to be at pi over 2, right? So essentially, you need to fix the angle. So where is the angle? So we're gonna put it like this. It's gonna be where result. So essentially, you don't need to do too much of the coordinate transformation. You just need to rotate them, right? So you just need to rotate them, and you rotate them by a half of a pi, right? So this is gonna be half of a pi, and that will also not work because A10 returns you coordinates all over the place. It could be negative, it could be positive, whatever the fuck, is just all over the place, which is not convenient to work with. So let me actually have half of a pi somewhere here. So it's going to be half pi, pi over 2. And we're just adding half pi here. So here's the thing. You want to normalize this angle. You really want to normalize this angle. And one of the ways to normalize this angle is to do something like mod over, over double pi, over the whole coordinate circle. So it's double pi. All right. Double pi is just 2 of this thing. Right. But here's the thing. Mod works with integrals. And what we have here instead are doubles. Right. Doubles are not integrals. They're fractional and floating and all sorts of stuff. They're not integrals, that's for sure. So in Haskell, you actually can have fmod. You can have fmod. It's actually called mod prime. So, and it's located in data fixed, so it accepts a real number and it can do like mod for doubles fixed. So that way you sort of normalize your stuff. Mod prime. There we go. And if you try to do that and take a look at the second part, 2732, 2732. So I don't think. Yeah, this coordinate transformation also screwed me over yesterday, and I don't think it's that useful of a challenge. Right, it's not that useful of a challenge, it's just like, doesn't add much to the problem in my opinion. It's just like, adds like additional unnecessary step, and makes you think about all of this like rotation, transformation, and like you could have actually removed that. Like, why force people to do this transformation? Is just doesn't add anything to the problem. To be fair, this problem was extremely disappointing. Like, the fact that you can just use very dumb solution is just like so unsatisfying. The only thing, interesting thing about this problem was solving part 2 in Haskell, where you had to realize that you need to use an infinite data structure to you know, simplify the process of keeping track of the state. I think that was cool. That's the only cool thing about this problem. But apart from that, kind of disappointing. But it is what it is, and it isn't what it isn't. So So yeah, here it is. Here is the solution. Did you guys like my solution for this problem? Isn't it a good solution? I think it's pretty cool. So I especially like yeah, this is already like the second time in Advent of Code where I had to use infinite data structures. And I'm starting to actually realize the usefulness of the infinite data structures, because they help you to keep track of the state. This is just one of the way of keeping track of the state. Like one way is to just pass the state as an argument all the time, which is really like a newbie way of doing functional programming. This is more advanced, and it actually makes the code easier to manage. Right, it just becomes like simpler. Yeah, you just construct infinite data structure that keeps track of the state for you, and it's so natural. It just works. It's pretty cool. It's pretty cool. So, yesu, kawai desu. All right, let's do a committee, I suppose. Readme md. So day 10 solution. Okay. Expected. Congrats with solving day 10. I didn't solve day 10. I'm sorry. So expected results. I'm too dumb to solve day 10. No, I'm too dumb to realize that for day 10 you need to use a dumb solution. That's how dumb I am. I wasn't smart enough to actually try the dumbest solution. I was just scared to use the dumbest solution. But so yeah, this is what it is. It is what it is, and it isn't what it isn't. Suffering from success? No. Infinite data structures are great for iterator-like computations. What is iterator-like computation? I don't understand that phrase, I'm sorry. So I guess, what do we have here? It's part 1, and there we go. So expected result, and yep. Day 10 solution, and I'm gonna push that right into the repo, and you can find this solution right here. So yeah, that's it for today, boys and girls. Yeah, we did a post-mortem of the day 10, and it's time for me to go. It's time for me to go. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all tomorrow. Love you. Mwah.